So let me just remind you what a proportion is. A ratio on the left equals ratio on the right. An equation with ratios on either side of the equal to sign is a proportion. Now the question says, are the numbers 1 2/3 and 5/6 proportional to the numbers 5 and 2.5? So let's set up the proportion first in the exact order that it's given. 1 2/3 is to 5/6 as 5 is to 2.5. Now, how do we check if this is a valid proportion? We could cross multiply, and when we cross multiply, we get 1 2/3 times 2.5 equals 5 times 5/6. Remember that when we multiply mixed numbers or divide mixed numbers, we have to first change the numbers, the mixed numbers, to improper fractions. So 3 times 1 is 3 plus 2 is 5/3 times 2 times 2 is 4 plus 1, 5/2 is equal to 5 times 5/6. So 5 times 5, nothing cancels. Make sure we check if anything cancels before we multiply the numbers. Nothing cancels, so we just go ahead and multiply. And what we see here is that the left side is equal to the right side, which means that the two ratios are equal, or it is the same as saying the proportion or the equation is valid. Now we're going to look at solving simple equations that look like this. 3x equals 27. The whole point of solving an equation is to get the unknown number, and in this case the unknown number is x by itself. So basically, solving an equation would be to figure out what x is or calculate what x is. Now, unless we get x by itself, it would be impossible to make that calculation. So the next question is, how do I get rid of the number 3 that is multiplied to x? And remember that we need to make sure that the equation is still valid. So the only way in which we could get rid of the 3 that is multiplied to x is by dividing by 3. So that way the two 3's cancel each other out. But what we do on the left side of the equation, we have to do exactly the same thing on the right side of the equation. So if we divide both sides by 3, so what have we done so far? Divide both sides by 3. If we divide both sides by 3, what we've done is solved for x. We cancel the 3's and x is equal to 9. So we could put it back in the equation. So 3 times x equals 27. We just said that x is equal to 9. We solved the equation. So let's put x, which is 9, back into the equation and check if it works. 9 times 3 is 27 equals 27. It works, so therefore our solution x equals 9 is correct. 7w equals 49. Notice that w is the unknown number that we're trying to figure out or calculate. Now, in order to calculate w, we have to get w by itself, which means we have to get rid of the 7 that's multiplied to w. If a number is multiplied to the unknown, the only way we can get rid of it is by dividing by the exact same number, so we can cancel it. 49 also has to be divided by 7. Whatever you do on the left, you do the exact same thing on the right. And remember, when you're solving an equation, you have to be organized, work vertically down this way. So once we cancel the 7s, we have W equals 49 over 7. And we need to simplify it before presenting it as the final answer. So 7 times 7 is 49 over 7. The 7's cancel and W is equal to 7. What we've done is we've solved the equation. So when you solve an equation, make sure you have an equal to at every step. Show your work clearly. You have to work vertically down. Okay, and this is an organized way of solving equations in this case. So let's write down the original equation. 7W equals 49. If the answer W equals 7 is correct, when you plug it in, you have to get a valid equation. So 7 times 7 is 49. 49 equals 49. It's valid. So that tells us that our answer is correct. You always can check if the answer is correct by plugging it back into the original equation. Notice here that y is the unknown, and we have to get y by itself. And how do we get y by itself? 25 is multiplied to y. So the opposite of multiplication is division. So we divide by 25 to get rid of the 25 on the right, but remember to do the exact same thing on the left as well. Whatever is done on the left has to be done on the right as well. So this would be 25 times 2, which is 50, over 25. Remember, vertically down, put an equal to sign, cancel the 25s, and you have y equals, and once we cancel the 25s, I'm going to shift to this side, y equals 2. And that's the end of the problem. We've solved it. However, if it is easy to check it, it's a good idea to plug it back in and check if it works. Any calculation errors will show up here. If the two sides are equal, it means that there are no calculation errors. You've done it correctly and your answer is correct. If we made a mistake in any sort of calculations, we're not going to get a valid equation like this one. 1.4 equals 0.4z, just decimal numbers, but the idea is the same. Z is the unknown number, and we have to solve for z, which means get z by itself. 0.4 is multiplied to z. The opposite of multiplication is division. So in order to cancel it, we need to divide the right side and the left side with a 0.4. Whatever we do to one side of the equation has to be done to the other side of the equation to keep the equation valid or balanced. So we cancel the 4's, and I'm going to work vertically down here. 1.4 over 0.4 is equal to z. Remember that fractions cannot have decimal numbers in the numerator and denominator. So I'm going to go multiply with 10 in the numerator, multiply the denominator with a 10. And the whole idea is to get rid of decimal numbers. So instead of doing any sort of decimal division, I'm just going to work with fractions, which is much easier. Multiplying with 10 shifts the decimal point one place value to the right. Same thing in the denominator. 14 over 4 equals z. 14 over 4. I'm going to go 2 times 7, 2 times 2 equals z. Cancel the 2's. 7 halves equals z. And if you need to write it as a mixed number, 2 goes 3 times into 7, leaving a remainder of 1. So z is equal to 3.5. Let's just make sure you understand how that was done. 7 over 2, I'm changing it to a mixed number. 2 times 3 is 6. Subtract to get a 1. And that's how we get 3. It goes 3 whole times into 7, leaving a remainder of 1. The remainder brings us the fraction part of it. Okay, determine whether the given value is a solution to the proportion. So we have 14 over x equals 12 over 18, and x is equal to 21. So we plug the 21 back in. That's how we check if the answer is valid. So 14 over 21 we need to check is equal to 12 over 18. If this is a valid, that's a 12 over 18. If this is a valid equation, then we should get the two sides to be equal. 7 times 2 is 14, 7 times 3 is 21, 6 times 2 is 12, 6 times 3 is 18. 2/3 equals 2/3. This is one way of doing it. Or you could cross multiply. 14 over 21 is equal to 12 over 18. And when we cross multiply, so when I cross multiply, 12 times 21 is 252, 14 times 18 is 252, 252 equals 252. That tells me that the equation is valid. So there are two different ways of checking. Do it any way that you're comfortable with.